In each of figure A, B, and C, and D, the circle has 0 and radius 2. Determine the area of the shaded region in figure A. Well, this is a circle, obviously, so the area of the circle is pi r squared, and in particular what they want is the shaded region, which is a quarter. Now the reason I know it's a quarter is because of this angle right here. That's 90 degrees, that symbol, and 90 is a quarter of 360, which would be the full way around. So I divide by 4, and that's pretty much it. And the radius they told me is 2. Plug that in there, and this looks like it just becomes pi. So pi is the answer to part A. Determine the area of the shaded region in figure B. Okay, so now this time they want this little cap or whatever you want to call it. So that's going to be what I just figured out, which was pi, which is the quarter circle. Subtract from that the area of that triangle, which is 1/2 base times height, where the base is 2 and the height is 2. And that looks to me like pi minus 2. Part C. In figure C, triangle PQR is equilateral and has side length 2. Determine the area of PQR. Well, you can do it the long way or the short way. I always remember the formula for the area of an equilateral triangle. It's √3/4 times a squared, where a is the side length. Well, in this case, our side length is 2. So it would be √3/4 times 2 squared, which is just √3. And moving right along, we have part D. Determine the area of the shaded region in figure D. Okay, so this one here, what we have is, I'll draw it over here just to avoid making the diagram messy. So I'll call that kind of like a pi, right? And if you take away from that pi the triangle, you will get the cap. And the cap is this guy right here. That's what they're asking us for. Okay, so it shouldn't be too bad. The pi, we have to know what this angle is. Now, because it's equilateral, that angle is 60. Equilateral triangles have 60, 60, 60 as their 3 angles. So the pi would basically be the area of the circle, which is pi r squared, multiplied by the section of the circle that it covers. And in this case, it's 60 degrees. So it's 60 over 360. And that's how you'd figure out the area of that pi. Now the triangle, I think we just figured it out. It's a 2 by 2 by 2 triangle, right? So we just figured it out in part C. That's √3. And I think that's it. Yeah. So then that's going to be the cap. So and then of course the radius is 2. So this is going to be 2 squared. 1/6 minus √3 is cap, like that. So this is going to be, I believe, 2 pi over 3 minus √3. And that solves the question. A pattern of figures is shown below. Figure 1 is a regular pentagon with length 1. Figure 2 is a regular pentagon of side length 2. Drawn around figure 1 so that the two shapes share the top vertex T and the sides on either side of T overlap. The pattern continues so that for each n greater than 1, figure n is a regular pentagon of side length n drawn around the previous figure so that the two shapes share the top vertex T and the sides on either side of T overlap. The ink length of each figure is the sum of the lengths of all of the line segments in the figure. Determine the link length of figure 4. So you guys understand, right? This ink length was 1, 2, 3, 4, 5, and that's why it says 5 there. This ink length, that's 2, 4, 6, 8, 10, 11, 12, 13. That's why the ink length is 13, and then so on, right? So what they're saying is find the ink length of, what are we saying here? Of 4. Okay, so that shouldn't be too hard. Let's do this. I guess, do we have to do it manually? Yeah, probably. So I don't think I really need to draw it. I'm not trying to show off, but I think I can probably do it just by the pattern here. So if it's length 4 for figure 4, right? Figure 4 would have length 4. So you're going to have 5 of those guys. and then you have to count only 3. Like this how this is only 3, 1, 2, 3, and then 1, 2, 3. It would be only 3 of the smaller ones. So 3 of length 3, and then 3 of length 2, and then 3 of length 1. I believe that is how you do it. So that's 20 plus 9 plus 6 plus 1. So that's 6 plus 3. Sorry, that's 38. Okay, so that takes care of that guy. Determine the difference between the ink length of figure 9 and the ink length of figure 8. Okay, so this is, I'm pretty sure this is where a pattern comes in. So let's just put the figures here. So we got figure 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. And then we'll put the ink length like here. So that's going to be 5, 13, 24, 38. Okay, now the other ones I don't know, but I think I can figure out the other ones with the pattern. Let's see. What's the difference there? That's 8. What's the difference there? That's... hold on. The difference there is 11. The difference there is 14. Ah, okay, I saw a pattern. It looks like the difference is going up by 3. So the difference from here to here would be 17. The difference from 5 to 6 would be 20. The difference from 6 to 7, 23. 7 to 8, 26. And difference from 8 to 9 would be 29. Yeah. So I knew there was some sort of a pattern. Okay, the part C, determine the ink length of figure 100. Okay, so obviously there's a pattern because you're not going to do this manually. Okay, so let's see here. How do we figure this out? Okay. So you start off with a 5, this guy right here, and then you adding 8, which is this, and then you're adding 11, and then 14, and then 17, and so on, ... So what is the pattern? Oh boy. I think that it's going up by 3, so I'm going to try to isolate that 3. The 3 seems to be the only thing that's going to help me. So this looks like 5 plus nothing, so 3 times 0. That 8 is a 5 plus 3 times 1. The 11 is a 5 plus a 3 times 2. Ah, okay, I got it. I'm seeing a pattern here. Is that right? Yeah. And the 14 would be a 5 plus a 3 times 3. Okay, so and so on. So that tells me that this is of the form, I'll just write it over here, 5 plus 3 times something. Now that something is what? If this is n, it would be, I think, n minus 1. Like if the total number is n. So for example, for these 5, there's 5 terms. So the 5th term would be 4. 1, 2, 3. Oh, I didn't put in the 5th term actually. The 17 would be a 5 plus a 3 times 4. Yeah. Okay. All right, so that's very good. So that means the 100th term would be 5 plus 3 times 99. All right, so hopefully I've done this correctly. Okay, so now I think I can add it up. So we got, how many terms do we have? 100 terms, so the 5 will be 100 times. And then we have a 3, and we can factor out the 3 and then get 0 plus 1 plus 2 plus 3 plus 4, ... all the way till 99. Okay, I believe that's going to help us. So if this is 500, and then this will be 99 times 100 all over 2. And when you crunch out these numbers, you will get 15350. So with a little bit of pattern recognition, you can get this question solved pretty quickly. 6 swimmers swim lengths in a pool that is 100 meters long. They start at the same time from the south end of the pool, swim to the north end, swim back to S, then to N, and so on. So they each swim at a constant speed and each turns around instantly at both ends of the pool. The swimmers are said to cross when they pass each other in the pool while swimming in opposite directions. We also say that they cross if they arrive at N or at S at the same time. Suppose that Alice and Betty cross at S after Alice has swum 400 meters and Betty has swum 600 meters. How many times before this point did they cross? I've never heard this word before. I thought it was swam. Oh well. Anyhow, so let's figure this out. It might take a little bit of thinking here. So first you have Alice, and then we have Betty, and we have speed, distance, and time. The speed of Alice I will call SA, and the speed of Betty I will call SB. And then the distance, they have in this question they have set it at 400 for Alice and 600 for Betty. And the time, now if they are meeting at that point, meaning after Alice has swam 400 and Betty has swam 600, then that time is the same. So if this is T, this is T also, right? Because they end up at the same place after 400 and 600 meters respectively. Okay, so now of course you can use that formula. Speed is equal to distance over time, and then we'll isolate it for time, so distance over speed. Now their times are equal, so the time for Alice is the same as the time for Betty. So D over S for Alice would be 400 over SA, and D over A for Betty will be 600 over SB. And then when you solve for this, you will get that SA is equal to 2/3 of SB. So that's important. That fact is important. So that means that somebody is swimming faster, and that means that, for example, if SB, let's say, is 90, then SA would be 60. So Betty's obviously swimming faster. So Betty can swim. Betty can swim 1.5 times farther over the same time period. Yeah, 3/2 basically. 3/2. Okay. All right. I think that's a pretty good start. Now we got to figure out how many times did they meet before that 400, 600. Okay, so I think there's a few scenarios. The first scenario, this is the Alice and Betty. Alice gets to that point. Betty is a bit faster, so she gets there, and then she turns around, and then that's when they meet. They cross, basically, at that point. So we'll just call this X, and then this is 100, and then this guy here would be 100 minus X, like that. Now, we take this fact into consideration, this fact right here, that Betty can swim 3.5 times faster. So 3/2 would be the ratio of the distances traveled by Betty and Alice. So Betty's distance looks like 100 plus 100 minus X, and Alice's distance was just X. So that is the algebra. And if I cross multiply, I get 3x, and then I get 400 minus 2x. So 5x is equal to 400, and then x is equal to 80. And I think that's valid. As long as the x is between 100 and 0, I think that's valid. And then, of course, if x becomes a negative number or something outside of that range, then of course it'd be invalid. So this is one way, one example of how they cross. And I think we probably have to do a few more. So let's do the second one. The second one, I believe, is Alice is gone the full length and then she's come back, whereas Betty has gone 1 length, 2 length, and then come back. So remember, they have to be going in opposite directions for this to be valid. So now this is 100. We'll call this guy X. This is 100 minus X. And then these two guys are 100 and 100. So again, same thing, 3 over 2. Let's see, 300 minus X, I believe, is the total distance for Betty. And then for Alice, looks like 100 plus X. So if you cross multiply, well, you do the math. I'll just give you the answer. X is 60 here. So again, it's valid. And then the third one, let's keep going here in the same sort of pattern. This time Alice does 2 full lengths and then she does a little bit, and then Betty does 3 full lengths and then comes back there, and then back this way. So again, same thing. This is going to be this time 400 minus X over 200 plus X. And when you solve for this, you get X equals 40. And there's one final guy. Let's see here. That's going to be, let's see if I can set this up. 1, 2, 3, 4 on the way back. So coming close to 400 for total. And then for Betty, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How many would they be? I think one more. Yeah, obviously she has to come back. Okay. A lot of lines. So this time 3 over 2 is equal to, well, we got to label it. This is going to be 100 minus X. I didn't even label this one over here, but that's okay. You guys understand this would be X and this would be 100 minus X. So we got 500 minus X, and then over this one would be 300 plus X. Yeah. So this solves to 20. And then this is when I think we've exhausted it, because at this point, Alice is going to eventually just come back, and then she will have completed the 400 meters, and then that's when they meet for the last time. So we met 1, 2, 3, 4 times before they meet at that 400 and 600 routes. Suppose that Charlie and David first cross when Charlie has swum 90 meters. How many times will they cross again before arriving at S together for the first time? All right, in a similar way, we will set up the diagram. So put Charlie and David here. So Charlie's gone 90 and David has gone 100 and then comes back about 10, right? Well, exactly 10, I should say. So 10, let's just label that. Okay, so that's all labeled. And then we have to figure out the ratio. So D over C was the total distance that David traveled was 110 and then 90. So it's 11 over 9 is this ratio. Okay, so that's going to be very helpful. And then total distance traveled by both of them. Well, it looks like 90 plus 110, and that is obviously 200. So this is just an initial setup, and let's see where we can go from here. So suppose that Charlie and David first cross when they have swum 90, when Charlie has swum 90, swam 90. How many times will they cross again before arriving at S together for the first time? All right, so this side is S, and this is north. All right. Well, let's see. The next time they cross would be Charlie's gone the full distance and come back. let's say X. I don't know how much. And then David will have gone once, twice, and then come back to that point. Like that. And they will then cross. So this is 100 minus X. So the ratio this time for D over C, well, it's always going to be 11 over 9, but then we put, in terms of X, it would be 300 minus X. Yeah. And then for C, 100 plus X. So this is the algebra that you're going to solve. And when you do, you get X equal to 80. Okay. And then the total distance traveled, total distance. If X is 80, then it's going to be 180 for Charlie, and for David, 220. And that is a total of 400. Okay. All right. So that, and you can kind of keep going like that, and you know, you just do just like how I did in part A, and then you'll eventually see that these total distances are always multiples of 200. So the next one's going to be 600, and then 800, and then so on. So we have to figure out how much longer we're going to go. I'm not going to do it manually for every single scenario because there's probably many of them. But one thing is for sure is that the question actually helps us out a little bit, that they say they eventually arrive back at S together. So eventually, if you were to continue this, you're going to get to a point where they arrive back at S, and if so, their distances would be a multiple of 200, right? Because you got to go there and back and then do that several times. And then we know that if their distances are a multiple of 200, so whatever they are, then they have to also have a ratio of 11 over 9. So whatever this is, this was, let's say, this guy is representing David, this guy's representing C, which is Charlie. Then this would be 11x, and this would be 9x. Yeah. Because it can't be 1100 over 900, because 1100 and 900 are not multiples, but it could be 2200. 2200 and 1800, where x is equal to 200. Is that right? Yeah. So then this distance is 1800, and this distance is 2200, and then of course that totals 4000, and that's consistent. Okay, I got it. So that means that this is when they meet back at S, when their total distance is 4000. So they're going to meet initially, when the question says, which is right here, when the total distance is 200. They're going to meet again at multiples of 200. So 400, 600, 800, and so on, all the way till we get to 4,000, I believe. Yeah, 4,000. So we have to now read this question carefully to figure out what it is exactly that they're asking. They first cross at 90. How many times will they cross again? Okay, so this one, they've already said, okay, we're not talking about that. How many times will they cross again? Before arriving at S. So this is when they arrive at S. So before they arrive, okay, so 3800 is when they arrive, when they cross again, and this is when they arrive at S. So we want, I got it. We want everything from 400 to 3800 inclusive. So that would be 18 times. Yeah, 18 times. So the answer, the specific answer to this question is 18 times. You just got to make sure you read the question carefully, because somebody might write 20 times or 19 times. But if you're doing that, you've added the initial time they cross, or you've also included the last time that they cross. So specifically what they want is just the 18 times. So they cross 18 more times before arriving at S. Farouk swims faster than Evan. Show that the length of time between two consecutive instances when Evan and Farouk cross is constant. So the speed of Farouk is greater than the speed of Evan. And every time they cross, let's see here, the sum of the distances, as we previously saw, was a multiple of 200. And since they cross at intervals of 200, and the question says that their speeds are constant, in the first part, I believe, there's somewhere in here, the swimmers are said to blah, blah, blah. Constant speed right there. Yeah. Okay, that's important. So they cross at intervals of 200 and their speeds are constant. So if that is the case, then the amount of time it takes for the total distance to increase by 200 will also be constant. And I believe that would be a sufficient explanation to show that the length of time between two consecutive instances when Evan and Farouk cross is constant.